Hello students, welcome to the lecture series of synchronous and induction machines. Today in this lecture video we are going to see the CO3, that is interpret the construction types, losses, efficiency, parameters and applications of three-phase induction motor. And in the previous lecture video we have discussed about the slip torque and speed torque characteristics. Here we are going to discuss about equivalent circuit and induction motor losses and then efficiency. So the equivalent circuit, we have to draw circuit step by step, that we can do it in the offline session. So the second part of this LO may be covered in this video lecture, losses and efficiency, that is the theory part. So we are taking this SO for this lecture video, explain losses and efficiency in induction motor. The first SO, that is 3.4.1, will be covered in the offline session. Here's the outline. We just have three different topics: power stages, various losses associated in induction motor, and then efficiency. Yeah, from this block diagram, or we can say it as a power stages. Note that it is called the power stages, power flow diagram of an induction motor. Yes, you know very well that the motors will have the input of electrical power and output of mechanical power, mechanical energy. Here the motor input, which may be denoted as P1. Here the motor input will be the three-phase supply connected with the stator winding. So the power input to the stator is P1, and from that power, stator winding will have some losses of its own. Stator, it is having copper winding, so that it will have the resistance. That resistance will offer some losses. That losses we call it as the copper losses. Yes, the copper losses in the stator side. And you know very well that the stator will have the core. So whenever we have the core, then there is a possibility of iron losses. Iron losses, or the combination of hysteresis and eddy current losses. So only when we were discussing about the construction, I told you that the core material used should have some more silicon content in order to reduce the hysteresis losses, and it should be laminated for reducing the eddy current losses. Anyways, we have those losses. We can minimize those losses by adding silicon content and making it as laminated piece instead of a solid piece. Okay, and this copper winding, that is because of the resistance offered by the conductor of stator. So from the given input power, some part of the power is lost in the stator side, and the remaining power will be given as input for rotor, that we are denoting as P2. And in rotor, we have the conductors or windings. If it is squirrel cage, we have the conductor bars. If it is slip ring type, we have the winding, copper winding. So there will be a copper loss in rotor side. And in the rotor side, we are not considering the core losses. Maybe by comparing with the stator side, the rotor core won't generate more losses. It may be neglected, but we should consider the copper loss which is there in the rotor. So now the P2, that is the rotor input, some part of the rotor input is lost in the rotor winding in the form of rotor copper loss. So, and the remaining power is the actual torque or the power developed, mechanical power developed in the rotor. So that is denoted by TG, gross torque, or the mechanical power PM developed in the rotor. And we have the shaft, right, and the shaft is fixed with the bearings, and after that we have the load connected with the motor. So in between the rotor and the load system there will be a bearing and shaft. So there comes the mechanical loss, that is due to windage, due to the wind when it is running. If there is a wind blowing there nearby, that makes some losses. And the friction is because of the bearing, wear and tear of bearing, and sometimes because of the shaft, alignment of shaft. So bearing friction losses. So in the mechanical power developed, we have small amount of losses because of the mechanical setup, and the remaining part will be available as the output power from the rotor shaft. That we call it as the HP rating, actual HP rating, horsepower rating. Okay, so the power stages, power from input to output at different stages, so that it is called the power stage, right? So a lot of losses: copper loss, core loss, mechanical loss. And in core loss we can have stator and then rotor, both the sides. So that is the losses and efficiency. Here in this picture it is more understandable. We have the power P1 motor input, which has the stator copper and iron losses, that is called the PCS and PCF, PCS and PF. And rotor input, so this P1 minus this PCS PF will become P2, and via air gap it is passing, and when it reaches the rotor, there we have the rotor copper loss. So this P2 minus rotor copper loss will give you the mechanical power developed in the rotor, or gross rotor torque. So after that it should be connected with the shaft. So shaft is fixed with the bearing. The windage losses and friction losses can happen, so that that PW will be there. So the TG or the PM minus PW will give you the actual output power which is available in the output shaft. So see in this picture, P1 is the active power input, stator copper loss, iron losses in the stator, and P2 will be the input for your rotor, and then rotor side we have the copper losses. Rotor side copper losses is there, and then when it goes to the shaft, there is a possibility of windage and friction losses. So finally you will get the output of mechanical power. Yes, then the TG, the cross torque, can be written as PM by 2 pi n. So how we are writing that? We know that power is equal to 2 pi nt by 60, 2 pi nt by 60. So with that relation we are writing TG is equal to PM by 2 pi n. So the shaft torque TSH is due to the output power P out, so that TSH will be written as P out by omega, P out by 2 pi n. So the difference between TG and TSH equals the torque lost due to friction and windage loss in the motor. Yes, TSH is the end shaft, TG is the cross torque. In between there are some losses due to the windage, due to the friction. So TG minus TSH will give you the losses, friction and windage loss. And note that where is that 60, since the n is in RPS, so there is no need of 60. Otherwise we have to put it as 2 pi nt by 60, right? If you are making RPS, no need of 60. But in real case, it is in RPM, so we are rewriting the equation, that is TG is equal to P2 by 2 pi ns by 60, which can be written as 60 by pi into P2 by ns, and that 60 by pi can be written as 9.55, 60 by 2 into 3.14. So that will be 9.55 P2 by ns. Then PM by 2 pi n by 60, which is equal to again 9.55 PM by n Newton meter. So the TSH will be P out by 2 pi n by 60, which is equal to 60 by 2 pi into P out by n, which is 9.55 P out by n. So that's all about the losses and efficiency occurred in induction motor. Thank you.